Good morning, students. Students, this lesson is for class 10th for the subject of physics, and today we will be learning the procedure to do the numericals of exercise 1A. These numericals are given on page number 11 of your physics textbook, Concise Physics by Selena Publications. So you all are required to open your physics notebook and your physics textbook at page number 11. So children, first of all, see the first numerical, the statement of first numerical in your textbook. It says that the moment of a force of 10 Newton about a fixed point O is 5 Newton meter. Children, while reading this first line, write down what are the things given to us. The moment of a force of 10 Newton. Newton is SI unit of force. Thus, write down force is equal to 10 Newton. Write down along with me. Write down force is 10 Newton. And 5 Newton meter. What is 5 Newton meter? Newton meter is SI unit of torque. Excellent. So torque is given to be 5 Newton meter. Now calculate the distance. The question is calculate the distance of the point from line of action. Children, we know the formula that torque is F multiplied by R, force multiplied by perpendicular distance. So in this question, we will be finding R by taking ratio of torque and force. So write down the answer. How to write? Torque is 5 divided by force is 10. So 5 by 10 is 0.5. And what will be the unit? It will be meter. So the unit is meter. Now see the question number second. Children, this second question you will do yourself. Coming to the third question, see. Question number 3, a wheel of diameter 2 meter. So this is a wheel of diameter 2 meter is shown in the figure with axle at point O. Children, axle means the pivoted point. So now a force of 2 Newton is applied at point B as shown in the diagram. You are supposed to find moment of force about the center and moment of force about point A. Children, now listen. Kindly pay attention, everyone. Now, children, in this particular question, force is applied at point B, at the upper point here. So at point B, force is applied, and how much force is applied? It is 2 Newton. First step is to find the torque at point O. That means force into distance between the line of action and the pivoted point. So children, force is 2 Newton. And what is R? Children, the diameter was given to be 2 meter. The diameter was 2 meter. So O to B distance is radius, and it will be how much? 1 meter. So the answer will be 2 into 1 is 2 Newton meter. And children, since torque is a vector quantity, you have to give its direction also. Now see, if I apply force on the upper side, what will it do? It will turn the wheel in which direction? What kind of direction is this? It is a clockwise direction. So what we will be doing, we will be bringing the force near to the pivoted point. Bend the force towards the pivoted point such that you will get the direction. And in this case, the direction is clockwise. Similarly, if we want to find torque at point A, again the formula is force into R. Force in this case is again 2 Newton. But what is the distance between line of action of force and point O? See in the diagram. What is the distance coming? Write down in your notebook what will be R here. Yes, it will be 2 meter. Excellent. Very good, children. So 2 into 2, 4 Newton meter. And children, the direction, torque is a vector quantity. Write down, hurry up, very good. Write down what kind of rotation will be. The torque will be producing an effect of rotational effect in clockwise direction. Simple? Understood everyone? Very good. So children, in this manner, we have got the answer, and in your PDF also, we have written that why we are taking the direction to be clockwise. So just read these points written in brackets. It will tell you how we are taking the directions. So children, coming to the fourth question, a very important question. First of all, let us see what is given in fourth question. Now, in your fourth question, children, read the question from the book. The diagram shows two forces, F1, that is 5 Newton, and F2, that is 3 Newton, acting at points A and B. So in your textbook, children, there is question given to us, and in which we are provided with forces. F1 is 5 Newton. F2 is, draw the diagram side by side, 3 Newton. This is point B and point A. Fourth question we are talking about. And children, there is AB is the rod pivoted at point O. The pivot point is O, such that AO is 2 meter while OB is 4 meter. This whole thing is given in the diagram, which is already provided to you. Now, children, stop writing, pay attention, look here. So the first part is, they are saying find the moment of force F1 about point O. So moment of force means we have to find torque. What we have to find? Torque. So torque produced, or we can say rotational effect produced by F1. How to write down? It can be written as F1 multiplied by R1. Torque 1. Let us say it as torque 1 is F1 multiplied by R1. So children, how much is the force F1? It is exerted downward, and what is the value given? 5 Newton multiplied by R1. R is the distance between line of action of force, That means where the force is applied and the pivoted point. Okay, so what is the distance here? See, it is 2 meter. So the answer comes out to be 5 into 2, 10 Newton meter. So torque produced at point A is 10 Newton meter. Now children, torque is a vector quantity. It should have any direction. Children, just pay attention. Since torque produces rotational effect, thus there can be only two directions of the torque, either clockwise or anti-clockwise. Now let us see what happens with F1. Children, pay attention. Whenever there is a force and you want to find the rotational effect, you just move the force towards the pivoted point. So that means try to rotate it towards pivoted point and see what kind of direction is this. See, your force F1 was acting down. Bring it towards O. Towards. Don't take it far away from O. Bring it near to O. So this is it clockwise or anti-clockwise? See, it is anti-clockwise. Suppose this is 6 in the clock written here 6, then it will be 5, 4, 3, 6, 5, 4, 3, isn't it? So this is counterclockwise, or you can say anti-clockwise. So from F1, rotate it towards O. What is the direction coming? It is anti-clockwise. So children, first part is done. Now I want you all to try to find the second part yourself. Kindly pause this session and solve yourself the value of F2, moment of force, F2 about point O. Do yourself now. Try it, very good. Second part, do yourself. So, if you want to find tau, torque 2, then you will write down F2 multiplied by R2. F2 is how much? See, F2 is 3 Newton and R2 is 4 meter. So 3 into 4, 12 Newton meter. Check the direction. F2. Now how to rotate it? Bring it near O. So what kind of direction is this? See the needle of the clock also moves in the same direction. So it is a clockwise rotation. So here the torque, the rotational effect is 12 Newton meter and in clockwise direction. So children, I hope this much is clear. First two parts. Now let us do the third part. For third part, children, look, tau 1 we were having it as 10 Newton meter in clockwise direction, while tau 2 comes out to be 12 Newton meter. In which direction? Sorry, this earlier one was our anti-clockwise direction. 10 Newton meter was anti-clockwise. while 12 Newton meter was clockwise. Now the third part says, find the net effect at point O. That is total moment of the two forces, total moment at point O. So how to find? These both are in opposite direction. Children, when the forces or moment of forces are in opposite direction, so we will do subtraction between the two forces. If they were in same direction, if first was also clockwise, then I would have done addition because same effect of rotation is produced. But in this case, at one place, the effect is anti-clockwise, anti-clockwise, and the other it is clockwise. So since the directions are opposite, I will write down the bigger torque minus the smaller torque. So that means 12 Newton meter minus 10 Newton meter comes out to be 2 Newton meter. And the total result will be in clockwise direction. Why so? Children, F1 is producing an anti-clockwise moment and F2 is creating a clockwise moment, and clockwise moment is greater than anti-clockwise moment, isn't it? Anti-clockwise was 10 Newton meter while clockwise was 12 Newton meter. So it means that who is more dominant? Who is dominating here? Which rotation will have more effect? Clockwise. So the net effect will also be clockwise. Children, if torque 1 was 50 Newton meter, suppose torque 1 would have come 50. Then how to write down net effect? It would have been 50 minus 12. That would have been 38 Newton meter. And in which direction then? Then it should be anti-clockwise direction. You will be writing bigger force minus smaller force. And the direction will be of the bigger force. So kindly go through the question again. Understand what we have done. See, first you found the torque for the first force. Then you found torque for the second force. Then for finding the result, we did bigger torque minus smaller torque. And whatsoever is answer, it will be having the rotational effect of the bigger torque. I hope is it clear? Kindly go through it one more time, please. So children, in your PDF also, you can see the question is solved in similar manner, and while doing numerical, kindly show in dotted way the direction of clockwise and anti-clockwise torque. So children, try to do 7th question now yourself. In question number 7, a steering wheel of diameter 0.5 meter, the diameter is 0.5, is rotated anti-clockwise. How you are rotating? In an anti-clockwise rotation. By applying two forces, each of 5 Newton. So you are applying how many forces? Two forces of 5 Newton magnitude. The question is draw the forces, draw the diagram and calculate the moment of forces. Children, you can see the diagram in the PDF. Here, so here torque at point O we have to find. the direction of forces. One I am applying in an upward direction and the other I have shown in downward direction. In this way, what will happen? An anti-clockwise rotation will occur. So children, torque at point O due to F1 will be 5 Newton multiplied by, what is distance here? It will be half of 0.5, that is radius. And the direction of rotation will be anti-clockwise. Similarly, for F2, the direction will be again anti-clockwise. Now, if you want to find the net effect, both the directions were same. And if we are having same directions, we will add the two moment of forces. So thus, the total effect will be 1.25 plus 1.25, which comes out to be 2.50 Newton meter, and the total effect will be also in an anti-clockwise direction. Children, now let us consider the principle of moments, because we will be doing these questions. So children, just see figure number 1. Here we are having a seesaw. What is it? Suppose this is a seesaw, and on the seesaw at point A we are having 50 Newton force, while at point B a person of 80 Newton is sitting. So the forces are 80 and 50 Newton. Children, the weight of the body always acts downward, and the distance between pivoted point, that is P, this pivoted point is at a distance of 2 meters from both the points A and B. So let us find the clockwise and anti-clockwise moment. Children, first of all, 80 Newton force rotated towards point P. This is an which direction? Anti-clockwise direction. So here, first of all, children, what we will do, I will find different torques. First of all, let us find torque at point A. Rotate the force towards P. It is a clockwise direction, see. At point A, the force is rotating in a clockwise direction. The rotational effect is clockwise. So for point A, we can find torque as 50 multiplied by 2, that is 100 Newton meter in clockwise direction. And for B, it is 80 multiplied by 2, that is 160 Newton meter, but in anti-clockwise direction. Now see students, are both the torque equal? No, both are unequal. Anti-clockwise torque produced by B is greater than, more than point A. What does it mean? That if we were having seesaw, it will not be balanced, rather it will, what happen? B will be producing more bending effect, rotational effect as compared to A. So your seesaw will get disbalanced and will bend from point B because it is producing more rotational effect at the pivoted point. Similarly, now children, here in figure 2, in figure 2 also, we are having 80 Newton and 50 Newton forces acting at point P. If we rotate B surface towards P, it produces clockwise effect. And if we produce 80 newtons towards P, it produced which direction? Anti-clockwise direction. Now children, see figure number 3. We are having 50 Newton and 50 Newton placed at two ends of a seesaw. So the weight will be always acting downward. Rotate it towards point P. So if you see, A will produce anti-clockwise effect and force at point B will produce clockwise effect. Now let us find different torques here. In figure 3, the torque will be 50 multiplied by 3. 50 multiplied by 3 is 150 Newton meter and in anti-clockwise direction. While B, torque at point B will be also 50 into 3, that is 150 Newton meter, but in clockwise direction. So children, what is happening in figure 3? Torque of A is equal to torque of B. If A is bending in an anti-clockwise direction with 150 Newton meter torque, then B is also bending with the torque of 1 Newton meter but producing clockwise direction. So children, whenever such condition occurs, then we say that the seesaw is balanced. Why balanced? Because clockwise moment is equal to anti-clockwise moment. When clockwise moment is equal to anti-clockwise moment, then the rod or seesaw is said to be balanced, and balanced means that it will not bend from any direction, rather it will remain straight, horizontal. It will only bend if one of the torque, either clockwise or anti-clockwise, if any one of the force is producing more torque, then the bending will be in the direction producing more torque. But when the two torques are same, when the moment of forces are same in both anti-clockwise and clockwise direction, then the seesaw will remain balanced. Now children, before starting the numericals further, there are 2 points you have to remember for numerical purpose. First is the weight of a uniform rod. The weight of a uniform rod or a scale is concentrated at its center. So if we balance or pivot or support the center point, the rod or scale can be balanced. Children, I want you all to take out your scale. You are having a scale of 15 centimeter division. Okay. So this is suppose scale having 15 centimeter division. This scale you are having in your geometry box also. So at a point of 7.5 centimeter, you keep your finger below the scale. You keep your finger below the scale and you can balance the entire scale. Your scale will not fall. So I want you all to keep your finger straight, and on that straight finger, you put a scale such that at your finger, you are having 7.5 centimeter. Now your scale will be balanced. It will be horizontal. But if you move your finger towards one of the end, so what will happen? Now your scale will bend from the other end. It won't be balanced. It will fall down from the other end. So this we will do further in numericals also. Do this activity, try it. Take a break of 5 minutes. Take out your scale. Balance it on your finger. Hurry up. Now children, further, second point is, if anti-clockwise movement is not equal to clockwise movement, if they are not equal, then the object is not balanced. It is imbalanced. And if they are equal, then the object is balanced, as we did earlier also in that example of 80 and 50 Newton. So children, further, let us do one example, very important example. On a seesaw, there are two children of mass 40 kilogram and 60 kilogram. They are sitting on one side of the seesaw at distances 2 meter and 2.5 meter respectively from its middle. Children, let us draw a seesaw where middle point is pivoted and two children of mass 40 and 60 are sitting on one side. One side means on the same side. Let us take those students as A and B. Respectively, the word respectively means that 40 kg is at 20 meter and 60 kg is placed at 2.5 meter. Now let us do the complete diagram. So at point A, weight of 40. Listen student, mass was 40 kilogram. Means weight is 40 kilogram F. 4 kg F. And weight always acts downward. Similarly, 60 kg F means downward. Now children, if on a seesaw, two people are sitting on one side, what will happen? The seesaw will bend from this side like this because two weights are acting down. And in the question they are saying, where should a man of 94 kilograms sit to balance it? Where shall I place that person? Shall I place here only with the students, with the children A and B? Or shall I place at any other point on the other side of pivoted point? Imagine this scene, that if you are having two people already sitting at one side, if I place third person also here, then what will happen? The seesaw will further get deviated downward. But what I want to balance it. Balance it means I want to bring the other part of seesaw down. So I'll place the other person on the right side of the pivoted point, which I have shown as C. And 94 kilogram force is the weight of the person. Children, let us rotate the forces. 40 kgf towards P shows anti-clockwise direction. 60 kgf towards P, again, which kind of rotation? It is also anti-clockwise. While 94 kgf will produce clockwise rotation. Children, the question was, where should a man be sitting to balance it? So let us say the person is sitting at point X from the pivoted point on the other side. Now in this case, since the question was of balancing the seesaw, we will say that sum of clockwise moment, first of all, you will write down like this. For seesaw to be balanced according to principle of moments. According to principle of moments, sum of clockwise moment should be equal to sum of anti-clockwise moments. Children, you can see the diagram in figure 4. I have shown all the directions in a dotted manner, and you will be also drawing the diagram as shown in figure 4. Now, first of all, clockwise moment. It can be written as force of man multiplied by distance of man from the pivoted point. What is torque? Torque is force multiplied by the perpendicular distance between force and pivoted point. So therefore, for clockwise moment, it is force into R of man, which should be equal to the force and perpendicular distance of child A plus force multiplied by perpendicular distance of child B. That is, sum of clockwise moment should be equal to net sum of anti-clockwise moment. This is always possible when the two are balanced forces. So let us put the value. Force can be written as mass into gravity, acceleration due to gravity. So 94 multiplied by g multiplied by x distance is equal to 40 multiplied by g multiplied by 2 meter. While in case of 60, it will be m is 60 multiplied by acceleration due to gravity, and the distance was 2.5 meter. Children, from the right side, you can bring g common, small g common. It can get cancelled out, and then you can find the value of x, which comes to be approximately 2.446 meter. So students, further I have given you question number 2. You have to draw the diagram and try it yourself. The question is, a uniform meter rule is pivoted at its midpoint. Meter rule means 100 centimeter rule. 1 meter rule. 1 meter means 100 centimeter. It is pivoted at its midpoint. So that means, what does it mean? If it is 1 centimeter, the pivoted point is at center. So the distance from one edge is 50 centimeter. A weight of 20 gram force is suspended at one end of it. So you have placed 20 gram force at one place. The question is, where should I place 80 gram force to keep the rule horizontal? I don't want it to be tilted. I want it to be horizontal. That means I have to balance it. So pause it right now. See the question on the screen. And now try yourself. Draw the diagram. Place the forces. Write down all the distances in centimeter, please. Now students, your diagram should look as shown on page number 7 of your PDF. I have placed the force, 20 gram force, at point A such that it will produce an anti-clockwise moment. Pivoted point is shown and 80 gram force is placed on other side of the pivoted point. Why on other side? See, if you are having 20 gram force here and you place here 80 also, the rule will become tilted. So to balance it, I will place it on other side. Now write down for balancing. What do we require? Torque of clockwise moment should be equal to torque of anti-clockwise direction. So what is clockwise? 80 gram force. So 80 multiply by G multiply by the distance between this is, what is the distance here? So what is the distance here, children? Distance is this CP, which we have to find. So that CP, let us take it as X, which we have to find, is equal to 20 gram force, 20 into G multiply by AP. Children, if total distance was 100, then AP is 50 centimeter. So you just find the answer, cancel out the things. You can see the solution further in your PDF also, and you'll be able to solve it. Children, further, in the same manner as we did this question, question number 8 of your textbook is to be done. You draw the diagram, which is again drawn in your PDF and solved in your PDF, but I want you all to try it yourself first of all. And children, with this, we are ending this interactive session. You all are required to go through the video one more time and then redo all first 8 numericals yourself again to understand the concept in a better manner. Thank you, students, and have a nice day.